Hello everyone, welcome to the series of the USCIS Coding Challenge application video walkthrough. In this channel, you are going to see how Anika Vital team prepares, designs, and implements a system with application and infrastructure components and packed solution to meet the customer's requirement. In the last session, we have read the prompt from the customer, understand how it impacts our application design, and come up with a draft system picture. Today, we are going to focus on service selection and component design. I wish it does not only explain how our team completes the task, but also give you an idea on how to choose the appropriate technologies to meet your customers' requirements. For this session, I divide the content into 4 pieces. We'll look at some selection criteria to measure if a candidate solution fits our scenario, then move to the individual layer and pick up a development stack and its associated deployment option. We will end this session by joining the selected development task and the deployment platform to meet the customer's requirements. Okay, let's get started with the selection criteria. In last session, we have extracted and analyzed the prompt from the customer. Compared with the original user language, the extracted requirement list does not contain the business details and makes it more generic and easier to follow. It also gives us the keyword to search for a common solution. We also come up with a draft system workflow. We have the UI layer to interact with the user, the microservices to represent the business domains, and some other services to enable the notification, user management, verification, and storage features. In addition, we also consider the speed of the delivery, the current technical stack that the customer is using, and the running cost. According to the collected requirements, we are able to pick up a service for the front-end application. React is a powerful and popular JavaScript library for building user interface, particularly single-page applications. Here are some key benefits of choosing React for our front-end development. Component-based architecture. React allows you to create module and reusable components, which helps in maintaining and scaling the application. Each component manages its state and logic, ensuring separation of concerns. Performance optimization. React uses a virtual DOM to efficiently update and render only the components that change, minimizing expensive DOM operations. React's reconciliation process ensures updates are fast and accurate. Flexibility. React has a rich ecosystem with tools and libraries like React, Router, Redux, and Net.js that make development easier and more efficient. It integrates well with other libraries and frameworks, allowing flexibility in building tailored solutions. Developer experience. JSX simplifies writing components by allowing you to use HTML-like syntax within JavaScript. Tools like React developer tools make debugging and performance analysis straightforward. The API is simple, making it easy for developers to get started. Strong community and ecosystem. A vast and active community provides extensive document, tutorials, and third-party libraries. Rich ecosystem and open source. React is backed by Meta, formerly Facebook, and has regular updates, ensuring it stays relevant with new web standards. Contributions from the open source community provide a wealth of plugins and libraries. Scalability. React excels at building dynamic, high-performing, and scalable applications with its robust state management capabilities. Tools like Net.js enable SSR, enhancing performance and SEO. Backward compatibility. React maintains strong backward compatibility, ensuring your existing codebase remains functional with new update. To run React application, we selected AWS S3 Bucket as a web frontend hosting service because of cost effectiveness. S3 hosting is inexpensive, as you only pay for storage and data transfer. No need for running servers or managing infrastructure. Simplicity. S3 is designed for static files, making it an ideal fit for static React apps. No need to manage servers or container orchestration. Scalability. S3 automatically scales to handle large amounts of traffic without manual intervention. Low maintenance. No need to patch servers or maintain runtime environments. Integration with CloudFront. Use AWS CloudFront for better performance via a CDN, HTTPS, and caching. We also considered the Docker container-based hosting solution and compared with S3 hosting. Docker container is necessary for dynamic applications requiring backend logic, real-time updates, or microservices. It is suitable for complex architectures where containerization benefits are leveraged. S3 is ideal for hosting static websites or SPAs with no backend or using APIs hosted elsewhere. It is great for cost-conscious projects with high availability needs. Using AWS S3 to host React web application involves leveraging the static site hosting capabilities of S3. Here are the steps to follow. Build your React application. Run npm run build in your React project directory to generate the static files, such as HTML, CSS, JavaScript, in a build folder. Create an S3 bucket. Log into your AWS Management Console or use AWS CLI to create a new S3 bucket. Ensure that the bucket name is globally unique. Enable static website hosting. In the bucket properties, enable static website hosting. Specify the index.html as a default root object, and optionally a custom error page. Upload the build files. Upload the contents of the build folder to the S3 bucket. Use the AWS Management Console, AWS CLI, or a SDK for automation. In our case, we trigger a Jenkins pipeline to execute an AWS CLI command for application artifact release. After selecting the front-end service, let's move on with the back-end development and deployment stack. We choose Spring Boot for API development, mainly because it is a framework that our customer is using in their current production. In addition, Spring Boot is a popular choice for backend API development due to its robust framework, developer-friendly features, and scalability. Spring Boot reduces boilerplate code with auto-configuration, letting you focus on business logic. Pre-configured dependencies make it easier to start without managing complex dependencies manually. It is ideal for creating microservices architectures thanks to its module design. It supports lightweight, standalone deployments with embedded web servers like Tomcat, JT, or Undertow. Spring Boot seamlessly integrates with databases, message brokers, and external services through Spring Data. Spring Security, and other modules. It has built-in support for RESTful APIs, simplifies creating HTTP endpoints. Spring Boot provides out-of-the-box monitoring and management endpoints, built-in tools to monitor application health. It also supports integration with monitoring tools like Grafana. Spring Boot includes testing tools like Spring Boot Test, making it easier to write unit, integration, and mock testing. It also works well with testing frameworks like JUnit. In addition, Spring Boot is suitable for building applications that can scale from small to large user bases. It supports containerization with Docker and orchestration like Kubernetes. Spring Boot has extensive documentation, tutorials, and support from developer community, as well as continuous updates ensure compatibility with modern development practice. From the operation perspective, we also love it. Simplifies configurations with externalized properties and YAML support. Profiles allow environment-specific configurations, which is useful for development, staging, and production setups. In terms of security, Spring Boot offers Spring Security for authentication, authorization, and secure APIs. It provides OAuth 2 and JWT support out of the box. By leveraging Spring Boot, we can save development time, simplify application deployment, and build highly scalable and maintainable backend APIs. Once the APIs are developed using Spring Boot, they need to be deployed to AWS. According to the requirements we gathered in the last session, microservice pattern, scalability, and containers are the key words. So the EC2 virtual machine-based computing service is out. The next question will be, which container hosting platform in AWS best fits our scenario? Since our DevSecOps pipeline is hosted in Kubernetes, we prefer to choose the same platform for the application. Besides, choosing Kubernetes over Amazon ECS, which stands for Elastic Container Service, for running API containers in AWS can provide several benefits depending on your requirements, environment, and long-term goals. Below are the key advantages of Kubernetes in this context. Kubernetes is cloud agnostic, enabling you to run your workloads on AWS and other cloud providers or on-prem. ECS is tightly integrated with AWS, making migration to other platforms more challenging. Kubernetes is designed to handle advanced container orchestration use cases such as blue-green deployments, canary releases, and hybrid workloads. Kubernetes provides ingress controllers and advanced networking options for fine-grained traffic management. Kubernetes has a vast array of tools and extensions, such as Helm for package management and Argo CD for GitOps deployments. Kubernetes benefits from a large open source community and support for integrations across various tools and services. Kubernetes offers advanced scaling features at both the pod and the node level, enabling better utilization and performance optimization. Kubernetes provides more flexibility in avoiding lock-in to a single cloud provider. This is particularly important for businesses that want to maintain deployment flexibility. Kubernetes automatically restarts failed pods, replaces unresponsive nodes, and reschedules workloads, improving the resilience of your applications. While Kubernetes has many advantages, ECS might be preferable if you prefer tighter AWS integration and a simpler setup. Your workloads are limited to AWS, and you don't need multi-cloud capabilities. You want to avoid the operational overhead of managing Kubernetes clusters. Ultimately, the decision depends on your organization's needs, skill set, and long-term goals. Kubernetes is often chosen for its flexibility and ecosystem, but ECS might surface for simpler use cases focused solely on AWS. Finally, we'll find out which database should be used to build this system. Before picking up specific database services, the first question we need to address is determining between relational database and NoSQL database. A relational database has listed use cases. Structured data. Data has a predefined schema. For example, tables with rows and columns. Relationships between data are well defined. such as primary keys, foreign keys. ACID transactions. You need strong consistency, isolation, and durability, such as financial systems, order management, or inventory. Complex queries. The application requires powerful querying using SQL, such as joins, aggregations, and filtering, such as reporting tools. Analytics on structured data. Standardized data. Your data model is unlikely to change frequently, such as ERP systems, CRM platforms. Small to medium scalability needs. You anticipate moderate growth in data size or user base that can be managed through vertical scaling. For example, more CPU and RAM. Compliance requirements. Data must conform to strict standards or regulations, such as healthcare records, legal documentation. An example of a relational database includes MySQL, PostgreSQL, Oracle, and SQL Server. NoSQL database, on the other hand, is for unstructured data with a flexible or dynamic schema, such as JSON documents, nested objects, key value pairs. Scalability. You need horizontal scalabilities for massive amounts of data or high traffic. For example, applications expecting unpredictable growth. High-speed operations. Prioritizing performance over strong consistency. Real-time applications like gaming, chat systems. Big data and analytics. You are handling large datasets that require distributed storage and processing. For example, IoT, telemetry, recommendation engines. Frequent schema changes. Your data model evolves frequently and you want to avoid migrations. For example, agile startups, rapidly changing products. Specific use cases, key-value stores, simple lookup operations, such as Redis, DynamicDB. Document stores, nested schema-less data, such as MongoDB, CoachDB. White column stores, large datasets. Graphic databases, relationships are the focus, such as Neo4j. By evaluating these factors, you can make an informed decision based on your specific project needs. In our case, the relational database works better. After choosing the relational database, we selected PostgreSQL. PostgreSQL offers several advantages compared to the other popular relational databases like MySQL, Oracle, and SQL Server. Its benefits arise from its open source nature, advanced features, and flexibility. PostgreSQL is a fully open source, meaning there are no licensing costs. You can freely use modify, and distribute it. Unlike Oracle or SQL Server, PostgreSQL doesn't tie you to a particular vendor, offering greater flexibility. PostgreSQL supports advanced data types such as arrays, JSON or JSONB, UUID, and XML, ideal for modern applications requiring semi-structured or complex data. PostgreSQL uses multi-version concurrency control, MVCC, allowing better handling of concurrent transactions without locking tables. PostgreSQL has a powerful query planner and optimizer. It supports advanced indexing methods, which improve query performance in specific scenarios, enables faster execution of complex queries by leveraging multi-core processors. Extensions make PostgreSQL highly adaptable for various specialized use cases. It allows programming in multiple languages, including Python, JavaScript, PLv8, and R, in addition to its native procedure language, PL/PG-SQL. PostgreSQL has active development and support community with regular updates and new features, comprehensive and well-maintained documentation. It runs on all major operating systems. PostgreSQL uses the PostgreSQL license, which is more permissive than Oracle or SQL Server licensing, giving business greater freedom in how they deploy and use the database. Great job! You have reached the end of this session. In today's session, we went over the process of selecting the services for each layer and matching the development component with a deployment platform. In the next session, we will figure out how to integrate those services to be functional together. I hope you enjoyed today's session. Thanks for watching and see you in the next video.